So we're wrapping up the chapter. We want to put everything together that we've done so far. We want to know that really this whole 2.5 weeks, we have done one problem. We've done only one problem. But we have solved it 4 different ways. We solved it by graphing, and we solved it by factoring, and completing the square and quadratic formula. So 4 different ways total just to get the same exact thing. Okay. Also, I'm going to change these to x's just to make it a little bit easier. The other ones are all x's. All right, so let's start off. I'm going to go through this with you, walk you through so you know what you need to do. Let's say, what is A, B, and C? Yeah, write them down. Write them down. So these are a few steps you do before you start basically any problem. You have to know what A, B, and C is. Some of you might have wrote it like over. That's fine too. So you have some sort of information written down for A, B, and C. If we do this wrong, then everything else is wrong. And unfortunately, a lot of people skip this step because like, well, I don't need to write it again. I can see it. And then they go ahead and plug in the wrong number if they're going to make it. Don't assume you're the only person that never makes mistakes. And this is not for you, this is for everybody. Anybody at any time can make a mistake. So we have that. Alright, now, given that this is -1, what direction does this open? Up or down? Down. Yeah. So we know that's going to open down. So before we start graphing anything, we already know it's going to be opening down. Is this vertex in the middle, is that going to be a min or a max? That's a max. It's at the top. So we also know that it's going to be a max. All right. What is the y-intercept? What is the y-intercept? So if I was to put this on an axis, right, where would it be crossing the y-axis? Right. And if you recall, that's what c is. So it'll cross at -5. All this information we know before, doing anything. Go ahead and write down the quadratic formula. Write that down. Another thing you should probably write down before you start any of these problems is to know this formula. Now, this formula is full of all this other pieces of information that we might need. So we know -b over 2a, that's the vertex, right, axis of symmetry. And then we have the plus or minus b squared minus 4ac. And what is this part called inside? The radical? What is that called again? Discriminant. Right, so we have to know that. So if directions say find the discriminant, you have to know what to do, what formula to use. And again, this other part that's outside is called the, right here, axis of symmetry. -b over 2a, -b over 2a. All the information you can see and know before even starting anything. All right, so let's find the axis of symmetry. Write it down. Go ahead and calculate it on your own. Plug in A, plug in B, see what you get. Now, as usual, I want you to do this with me, not look up, wait for me to do it, and then copy it down. You're not going to get better by copying somebody else doing it. You have to do it and then check to see if you did it right, make corrections as needed as you go on. You'll become experts. So this equals I got 6 over negative 2, which equals negative 3. And what does this mean? This is the x coordinate of the vertex. How do you find the y coordinate? That's what we have the equation for. So let's take our x value and plug it back in here, and we'll find out what y is. Negative x, negative 3 squared minus 6 times negative 3 minus 5. Go ahead and simplify that, see what you get. Order of operations correctly, and see what you get. Again, don't wait for me to do it and then you copy it down. Try it on your own so you know how to do this, so you know that you don't. You be more careful. Try it on your own. Done correctly, you should come up with 4. See why? So we have the most common mistake is that if you did negative times a negative first, you did not follow the order of operations. You have to square negative 3 exponents and then multiply. So that's why it's good to try it on your own and see what's going on. So we have this. Negative 3 times negative 3 is positive 9, but that negative is still in front. And we have plus 18. That's fine. So negative 9 and 18 makes 9. And then 9 minus 5 is 4. So a non-algebra mistake can make the whole thing incorrect, so you have to be very careful. So now we have our full vertex at negative 3, comma 4. So vertex is in the middle of the graph. We know this is the axis of symmetry going down the middle, negative 3, x is negative 3. And we know it's going down because set it right up here. It's negative. A lot of what's going to happen already. So let's figure out some more points. Plug in, let's say, we always go same direction and the same distance each direction. So let's go 1 up would be negative 2. 1 down would be negative 3. Another way of getting those is that we're just going from the axis of symmetry. That's why that'd be negative 4. Yeah. So we're going 1 to the left, negative 4, 1 to the right, negative 2. And we expect these answers to be the same number because of symmetry. So we'll plug in one of them, and that'll give us the answer for both. So the same way we did 1b, we'll have to do this. So we'll have y equals negative. I'm going to plug in negative 2 squared minus 6 times negative 2 minus 5. Go ahead and calculate that. If you made a mistake on 1b, try to not make that same mistake. means a 3. If I plug in -2, I'll get 3. If I plug in -4, I'll also get 3. So we get both sides. Good. Let's do the same thing. Let's plug in -5 and -1. 5, -1. And go ahead and calculate one of those. So you can plug in either -5 or -1 solution.
How did you get 3?
-4 plus 12 minus 5 is 3. Try again. I equals -1 minus 6 times -1 minus 5. Calculate it. Good. This equals 0. 0 for both. So that means right here. So now we can draw our parabola. Make sure we draw this parabola correctly. It should be curved. And gradually going outward. So never straight up and down. Not pointed at the top, but rounded. There's our graph. Now, what are the solutions to this graph? What are the solutions to this equation? Remember that when you're solving all these quadratics, the solutions are the x-intercepts. So the solutions to this quadratic equation are -5 and -1. Those are the x-intercepts. Alright, good. So if we find, when we find the discriminant, number 3, how many solutions should we have? How many solutions? Okay, so what's the discriminant? Go back up to the upper right-hand corner. What is it? Write it down. Write it down. Just the formula. Okay, and calculate it. See what you get. You can make a prediction already because you know how many solutions are. There are 2 x-intercepts, there's 2 solutions. So I should tell you what the answer is supposed to be. So I verify that. We have -6, 1, -5, 36 times 20 equals 16. So the fact that it equals 16, what does that mean again? Yeah, 2. So does it matter that it's 16? No, it matters because it's positive 16. So because it's positive, we have 2 solutions. And what are those 2 solutions? -5, -1, yeah. So like I said, we're verifying that we already knew there's two solutions, so we already knew we should get a positive for the discriminant because there are two solutions. So you know, everything is all tied together. Everything has to agree and match with everything else. It's all tied together. So when we go through and do the three methods of solving without using a graph, what should the solutions be? On all three on the bottom, what should the solutions be? Not -5 and -1. No, exactly. It's not a surprise. We learned how to solve one problem 4 different ways, so if we solve it one way, we get an answer. Of course, if we solve it the other 3 ways, we better get the same answer. Otherwise, things aren't going to work. All right, so let's factor this. We got, let's see, but -x squared minus 6x minus 5. And when you're solving, you say we get 0. Got a negative in front, so let's factor that out. Let's factor negative. Divide everything through by -1. Alright, now you go ahead and factor it. And solve. Get your 2 answers. Of course, they should come out to no way. So this is where we use the x method. What two numbers multiply to 5x squared and add to 6x? Came up with?
Five and one.
5 and 1. Now, is that a surprise that it's 5 and 1? Okay. Well, what was the solution that we already know the answer should come out to be? And -5 and -1. So yeah, everything matches. Everything matches. So we have negative x plus 5 equals 0. And we have x minus 1. X plus 1. Solve each one. Yeah. So yeah, no surprising, right? Factoring has to agree with what we graph. Has to agree. -5. So let's go ahead and try another method. Square. What do we get? What should the answer be here? -5, -1. Yeah, same problem, just using another method. Alright, so here we go. 6x minus 5 equals 0. And the beginning is identical. We pull out the negative, right? Between the square and factoring have similar beginnings. Now we've got the setup done. Let's actually complete the square. Go ahead and find the C value. That's the C. C value here. half of
Yeah.
half of 6 is 3. 3 squared is plus 9. And to make it equal to minus 4. 9 minus 4 is 5. Yeah, it's positive, not negative. So we factor the first 3 here. That's a perfect square trinomial. So what two numbers multiply to 9 and add to 6? 3 and 3, so we write it as x plus 3 times x plus 3, or x plus 3 squared. Got all this other stuff around it. And then lastly, remember, distribute that negative in there. So negative in there, and right here, we have negative x plus 3 squared plus 4 equals 0. Now, what was this called when we have it's written in this format? Yeah. So that is vertex form. So part of completing the square is putting it in vertex form. And it's called vertex form because you can tell by looking at it with no calculation, you can tell what the vertex is. So the vertex is, just by looking at it with no calculation, we have, what is it?
3 and 4. Negative.
Negative 3 and
Positive.
positive 4. Now, is that the same thing we got above?
Yes.
Negative 3, positive 4. So, of course, it has to match. Of course, it has to match. We're doing one problem. If we use the negative b over 2a and get negative 3, plug it back in and get 4. Of course, if we change it to vertex form, we better get the same thing. It's the same problem. It's not going to have a different vertex because I didn't graph it. Still got the same vertex. Okay, let's solve it now. So I'm going to subtract 4 on both sides. So I got equal negative 4. I'm going to divide by negative now and get positive 4 over here. Then I'm going to do the square root both sides. So I get two equations. X plus 3 equals 2, square root of 4. But also x plus 3 must equal negative 2. So 2 minus 3 is negative 1, and negative 2 minus 3 is negative 5. So of course, it's the same two numbers we expected to get. All right. One more time. A equals negative 1, B equals negative 6, C equals negative 5, and plug it all in. Alright, recommend we use the skeleton, so draw some empty parentheses for every parameter that we're plugging in. We got square root of B squared minus 4 times A times C all over 2A. good idea to start this way. If there's any mistakes here, it's not really algebra. It's more, oh, I forgot a negative, or I skipped a step. So a lot of people miss these not because it's difficult, but because they say it's too easy, and then they speed through it. So yeah, there's lots of little mistakes that can happen. So we got negative b, we got b, we got a, we got a, and we got negative 5. Now, this part, the discriminant, we already calculated it as 16, right? Already found out that right here, b squared minus 4ac is going to be 36 minus 20, which is 16. So far, I know this. I know I'll have 6 positive plus or minus square root of 16 all over negative 2. So 36 minus 20 is 16. Square root of 16 is just 4. So we have 6 plus 4 over 2
Is it negative 2?
and 6 minus 4. Oh yeah, these are negative 2's. So 6 plus 4 is 10. 10 over negative 2 is negative 5. 6 minus 4 is positive 2. 2 over negative 2 is negative 1. And of course, everything matches up. So you had a homework that had just the 3 methods at the bottom, the non-graphing. But now you can see what it looks like graphically as well. This is the first method we did, was to graph it and see where they cross. You also saw that there's 2 methods for getting the axis, the vertex here. You find the axis symmetry, get the x, plug it into the original equation, that'll give you the y. But you also have the vertex form, which was right here. That can also get you the vertex. So two methods for getting the vertex as well. One graphically, one non. All right, so all that together makes up 2.5 weeks, and it's really only solving one problem. It's just solving one problem 4 ways. So you're going to go through and do the same thing on number 2. And number 3, finish as much as you can in class, and then your homework, whatever you don't finish, plus the last page is your homework. Okay? But it's a lot of the repetitious, a lot of the same stuff. The big idea here is that if you get different answers for different methods, you don't stop and say, well, I guess that's just it. You understand that you're solving one problem, and if you get 2 different answers, you messed up somewhere. Don't just stop and say, oh, well, start looking for the mistake. You have to figure out which one's right, which one's wrong, and then try to look for that one negative you're missing. Okay, so go for it. Go do that, and then we'll see you tomorrow. Do a little review. Test is on Friday. Okay, test is on Friday. Final is next week. Casey is next week. For all the sophomores, you'll be in Casey testing Tuesday and Wednesday. So a lot going on next week.